So, to begin with, the disclaimer. Please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. So, good evening, everybody. Welcome to the June 19th main meeting. On the agenda tonight, we're going to have Dave do a presentation on his rocket launch. And then I am going to do a quick uh, DCR update. And then anytime after that, if you guys want to discuss anything else. So, without further ado, Dave, you ready to go?
I think so. Okay, I'm using Edge this time. So let me see if I can get this to work. Okay, start screen sharing. There, can you guys see that?
Yep. Yep.
Can you guys see my screen?
Yes, sir.
Yeah.
Okay. Some of the videos I've got audio. I don't know if audio will come through. If it doesn't, I may have to stop and reshare the screen. So this is about the rocket launch I was in. I was lazy, and this is a presentation I did before. I'm just going to use a couple slides from this, but I did this presentation back in 2019 to the homebrew group. I don't know if you guys can remember that, but it's a presentation I've done to a number of clubs. I did it at Mississauga, York region, Durham region, the clubs in Durham and York and Mississauga. So, it talks about introduction, who I am, what a rocket is, blah, blah, blah. And rockets come in all kinds of shapes and sizes. This year's a rocket, and the guy called it If Pigs Could Fly. And I've got a little slide showing it flying. So, you don't have to have a conventional rocket that's round and pointed at the top. Here's a rocket that it's got a stick and it flies. Here's another rocket here. This guy's Steve Eves. If you Google Steve Eves, the first link will come up. He launched the largest amateur-built rocket ever. He built a 1/10 scale Saturn V, and he launched it. I've got a little clip. I'm not showing the video, but I'll show you a picture of it compared to the size of a person. Thing is huge. So here he is. He's got a grandfather clock, and he flies that. So, I talk about why. I'm not going to go through this stuff. I'm just going to go through a couple selective slides just to set up the launch that I was at a couple weekends ago. So this all comes from a club I belong to called NAPIS. I was the president of NAPIS for a number of years. We flew high power rockets. So interesting picture here. History of this picture. So this guy here, Julian, that's his rocket there. He's flying. And one evening, I had arranged a beer and wings get together for the people at NAPIS. Julian was killed on his way coming to that event. He had a motorcycle, and he was killed on that motorcycle. I felt really bad that he came out. But wouldn't it have been really cool if we took Julian's rocket and we put Julian's ashes in that rocket and we flew it out at the Orangeville launch site, which you can't, it's illegal. You can't put eject things from a rocket such as ashes. But wouldn't it be cool if we would do that, and if we would launch Julian's rocket out at our Orangeville field and launch it up to about 10,000 feet, which we weren't allowed to do. It's illegal for us to do. But wouldn't that be really cool to honor Julian? This is being recorded, right? So there's the pig flying. You could see the rocket motor's up its butt and it's coming out. This is G slide, just talk about what the laws and model rockets and all that kind of stuff. But here's a slide showing Steve Eves Saturn V. look at the size of a person. Look at the size of the rocket he launched. So anyway, so there's a distinction between high power and model rockets. What I fly are high power rockets. So they're not a model rocket. The high power rocket weighs more than 1.5 kilograms. It flies a motor larger than a G impulse, and I'll talk about that in a second. You must be 18 years old and you must be certified to fly it. You have to write a test and you have to demonstrate you can handle large rocket motors. I've got my level 2 cert, so I'll show what that means in a second. But also you need minister's authorization to fly any high power rocket in Canada. So the NAPAS Club had a waiver where we could fly back when NAPAS is no more. The club is defunct. We at the rocket launch I was at recently, there was a couple of old NAPAS members there, and that's why I kind of went down. It was more to socialize with the NAPAS guys. But this year's the letter of authorization NAPAS had directly from Transport Canada, and NAPAS was the only club in Canada that was named, a club that was named. Every other club could fly under an insurance. The insurance that was supplying insurance to that club, they were named on the authorization. But NAPAS was the only club that had a blanket authorization based on the club. So here's a motor. I said about motors, so A to G are model rocket motors. And just the numbers here, the impulses, given the A to E is 1 to 40 Newton seconds. So just in context, if you hold an apple, the force of gravity on that apple is about 1 Newton. A 1 kilogram weight is about 10 Newtons. A motorcycle is about 1,300 Newtons, and a smart car is about 5,000 Newtons weight in the Earth's gravitational field, right? So if you compare that to like some of the rocket motors, level 1, you could fly up to 640 Newton seconds, 640. The level 2, which is what I have, you could fly up to 5,000, 5,100 Newton seconds, which means that, I could basically put one of these motors and put it in a smart car, and it would probably lift the car a little bit off of the ground. And then you got a level 3, which can go up to 41,000 Newtons. Now that could probably lift a person. And then I talk about rocket motors, and I'm not going to talk about that stuff. So, how big can we fly rockets? Well, here's a rocket I flew. It was made from a sonotube, and you can see the fins there. You can see it being constructed, and there's the rocket flying. That's the. Someone needs to mute themselves. So there's my rocket flying there. I've got a video showing it flying. I'm not going to bother showing that, but I just want to motor through this so I could get to what I flew a couple weekends ago. So most rockets, you've got a motor and it's got a propellant that burns, and then you've got a delay charge, a delay that burns, and then an ejection charge. And that ejection charge is what opens the rocket. So you would time the rocket when it takes off. You time it, you get a motor with a sufficient long delay. So it would be at apogee, that's the highest level. And then it would pop, the ejection charge would go off and the rocket would open, a chute would come out. And that chute opens and the rocket comes down. I've got a couple of videos here. These ones are kind of cool. This is so hopefully you guys, this will be able to show. Okay.
At LB5, Dave, somebody from Toronto, Canada is going to fly it.
Can you guys hear the audio there?
Yeah.
Yeah.
Okay. So I'm going to start again.
At LB5, Dave, somebody from Toronto, Canada is going to fly it. The Jordan 99 on a J285 in 3, 2, 1, goodbye.
That's a red lightning motor.
At LB6, Tyler from gonna fly the pit bull on a G46 in 3, 2, 1, go.
So I'm just showing you a couple rockets. So here, the reason I was talking about deploy, because this video kind of shows what I'm talking about. It's got an onboard camera. It's a model rocket. It's a D motor. And boom, right there it opens before it even reached apogee. It opened up. Now, if that rocket had gone up, like say thousands of feet, and we open a main chute at the top, and it's at say 5,000 feet, it's got a parachute. If there's any wind, that rocket, you're not going to get it back. We've had rockets where they went 6 kilometers before you can find the rocket. So we do something called dual deploy, and this is really important to what I'm going to be showing you, is that you have electronics on board the rocket, and what happens, the rocket launches. Now you can have the motor ejection charge open the rocket at apogee, the top, right? Or you could have electronics with something called an E-match. It's going to light that match. It's got some gunpowder, and it's going to blast the rocket open. And at apogee, you either have a drogue chute or you drogueless. No drogue, the rocket opens and it just falls. The rocket just free falls, and as it free falls, the wind doesn't carry it as far. So you open it at apogee, let it fall, then you've got some onboard electronics, and you open the rocket at say 800, 600 feet, and that way when the main parachute opens, it doesn't drift as far because it's only say 600 feet above the ground, so it won't drift as far, and you got a better chance of getting your rocket back. So there's all kinds of electronics you can get. That's an E-match. There's all kinds of commercial electronics. These next videos show, some of the onboard video for dual deploy. I'm not going to bother showing that. Here's me testing the charge. You could see, incidentally, here, you could see in the background, you could see my cubicle quad 2-meter antenna there.
Yeah.
So you can see the nose cone comes out, it pulls out the chute. So that's a successful test, right? That's what you want when you deploy at that second dual deploy, when you want the chute to come out. You want to put enough charge in there, it opens the rocket and it's going to pull that chute out so it can open. But there's always failure.
3, 2, 1.
So this is why we test all this stuff, to make sure. So here's so all these testing that I did was for this rocket launch here. This one's kind of cool. I'm going to show this. So this is not at the launch I was just at. This launch was back in 2015, I think, or so. And it's the Kaputnik. It's flying on a K560. This video's on YouTube. I just shortened it and I included it here. So this just going to go through a little bit of the. So if you look, the rocket has 3 components. It's got the main part, that's where the motor goes in, a lower payload bay that connects this part to that part, and then an upper payload bay that sits on top of here and connects this part to that part. So the lower payload bay has all my telemetry electronics and a downlink as well, and the upper payload bay has the dual deploy electronics. So you can see here, this is the upper payload bay, and it's got the dual deploy electronics. Those are commercial altimeters that I bought, and then the lower payload bay has got my homemade a telemetry module, and you can see here it's got an XB module for the downlink. It's got a GPS. It's got accelerometer gyros. That's a PIC microcontroller, right? And let's keep going. Here's the launch here. And I think you guys, let me put this back to full screen so you guys could see it, may see it better.
Where?
There it goes there. And then later on, that happens to be the wrong rocket. This is,
we were filming the wrong rocket then.
See, there's mine way over there.
this is my rocket here.
Okay, here, the
You could see the chute already opened,
and we were filming the wrong rocket.
and you
for
could
it,
see the
45.
sections, and it's coming down. It opened up at about 800 feet, and then here's the onboard. I had a camera mounted on the side of the rocket. That fly is going to get toasted, and it's going to fire off any second now. So that's on that K motor. Boom, and right there, the rocket starts to fall over, and it opened. So it opened right at apogee, and then so that works out pretty good. The rocket went up to 5,100 feet, almost 5,200 feet. Air starts is where you you fire a rocket while in flight. I'm just going to show you this. I love this video. This is a club project from Naples. It's called the Freaky Flyer. It's got one N motor with 3,000 Newton seconds. Then it's going to air start 4 K650 motors, and this is one of the most incredible
They have a whole bunch
launches.
of that thing. They have an N3180, Red Lightning, 4 K650.
Can you maximize it, Dave?
Stands for air.
What's that?
Maximize it?
They have a whole bunch of motors in that thing. They have an N3180, Red Lightning, 4 K650 smoke stands. Looks like the smoke stands for air starting. Boy, those black smoky motors lighting in the air is really cool. Fills the sky with smoke. It's great. At this rocket club, good luck. Freaky Flyer on pad number 2. Wire number 3, launching. 5, 4, 3, 2, 1, launching.
And right there, you could see the air start ship.
They have a whole bunch of motors like the sky with luck. At number launching 3, launch.
And right there, you could see the 4 K650 motors light while it's in the air, while it's flying. So that's the kind of stuff that,
And there's the max mode.
like, what's the guy, Elon Musk, SpaceX. And, all those companies do that. All those are other videos, talk about telemetry, recording telemetry. Here's the very first telemetry module I built. I used to fly this in some of the smaller rockets. And here's the data it would record. And here it shows going up to almost 1,400 feet in altitude. And the reason why you're seeing these steps, where it's a step, a step, a step, is because I'm sampling too much. I'm sampling too fast. So the altitude hasn't changed. So I was just sampling there too much. That Kaputnik rocket that I launched with my homemade telemetry module, here's the data from it. The blue is showing the velocity, and the red is showing the altitude. So all I did was I took the data from the accelerometers, integrated it to get speed, then integrated it again to get height. And it's showing the height in meters. Now these spikes here, that's when I go to write the data out to I²C memory. It messes up the timer. And so I get one data point that's wonky. But you can see the altitude goes up really smooth. And then here you see this big red spike coming down. That's when the motor ejection charge fires, and it pushes out the lower payload bay, and it sees a lower pressure. Well, it sees a higher pressure. Sorry, it's seeing a higher pressure because it shows a lower altitude. Way back when in the day when we used to have to find rockets, we'd have this little receiver, and it just had I think a Moxon antenna. It's the folded, two folded dipoles. And here's the transmitter. It was on 220 something megahertz, 50 milliwatts. And with this system, line of sight, you got, over 5 miles. So that's how we used to find rockets. Now, for us to actually use this, you had to have your amateur license. This is the reason why I got my amateur radio call sign, so that I could use this stuff legally. Because I didn't like the fact that, a lot of guys flying rockets would just go and get this and make up some call sign, give it to the guy, and the guy would embed the call sign in this transmitter. I wanted to do things by the book. And so now you use GPS and blah, 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 blah. Okay, so now let's talk about the rocket launch. I went through all that stuff, was just introduction. So this was a couple weekends ago. So, I had to decide what rockets I was going to fly. Here's my Kupitnik here, the big blue one. That's the one you saw that flew on the K650. This is the Jordan 99 you saw fly. So I have that. I have all these rockets here. So all these rockets are homemade. They're built from scratch, except for the Pitbull, which you saw launch. And this rocket here is called a vertical assault. Those are 2 kits I bought. Every other rocket I built from scratch. This vertical assault is capable of going Mach 1. What I took down was I took this rocket here. It's called the Blue Flame. I just named it that. It's homemade. I took that rocket down and I flew that. I took a bunch of other rockets down and I didn't fly any of those. So the question was, okay, I'm taking my rockets down. Do I do apogee, parachute, or do I do dual deploy? So I thought, okay, well, I'd fly one rocket, apogee, parachute at apogee, and another rocket I would fly dual deploy. So I've got commercial altimeters and commercial dual deploy controllers, but why would I want to use those? Why not just build my own? You guys should know me, right? So I ended up building my own. Here's a prototype of what I built, and here's the boards I sent away to JLC PCB. So I made my own dual deploy altimeter, a newer version. This one has ESP32 modules, so it's got a Wi-Fi downlink. It's got an SD card for recording data. It's got a pressure sensor for recording altitude, accelerometer and gyro. It's got a GPS, and it does dual deploy. So this is kind of how it came out. It's got a base station, and it's got the part that goes in the rocket. These are both identical ESP32s with an external Wi-Fi antenna. So I'm using a protocol called ESP Now. Between them, it's a proprietary ESP protocol. And so this here sits back with my laptop. I 3D printed a case so that it could be mounted to a stick or something. And this gets connected to my laptop. And this has an uplink, downlink to the unit that's in the rocket. So, you have to see a schematic. So here's a schematic of what I did. Here's the ESP32 module. Here's all the connectors. Here's a connector for the SD card. Here's a connector for the pressure sensor. Here's a connector for the GPS. And here's a connector for the gyro accelerometer module. And here's a connector for power coming in. V in is the power coming in, ground. And then these two other, this is a screw down connector, is for the dual deploy. So the way the dual deploy works, you got 12 volts feeding in to the E-match. And then the other side of the E-match is connected to V out, which is connected to these two MOSFETs in series. So when these MOSFETs turn on, this V out gets grounded. And so current flows through the E-match and fires it. The reason I used two MOSFETs is that I wanted to get try and get as much current, because I think these MOSFETs are only rated for a couple hundred milliamps. I figured with 2, I should get more than enough current to fire the E-match. And with all my projects, I got to put a CLI. So there's a CLI, a command line interface, where you could send all these commands to the module in the rocket. And on the SD card, it's got some files it maintains. And these files, you've got an F command, which lists the directory on the SD card. There's a log file. This is the log file here. So this is just logging events. As the rocket's flying, it's logging various events. Here's the startup sequence. It's setting up the timers and GPS and all the other sensors. It's setting up ESP now, and so that's everything gets logged in the log file. Then there's this FMS data bin file. And what that is, that's a dump. The sample time here is 50 milliseconds. Every 50 milliseconds, it reads all the telemetry data from the accelerometers, gyro, GPS, everything, and it just prints it to that file in a binary format. Because I did it that way so it's quick, because with ASCII, it's a lot more text, a lot more data going through. I wanted to minimize how much data was going in. So I had to come up with a way of testing this. Now, this is a prototype board I've got here. And so the way these altimeters work is that they're using pressure. So this is a plot showing atmospheric pressure in kilopascals versus altitude above sea level in meters. So this is elevation above sea level. So at 0 elevation, you've got 100 kilopascals. Now, this will shift depending on the temperature. This curve is temperature dependent, but ignore the temperature for the time being. So let's just say at sea level, the pressure will be 100 kilopascals. So at 50, you're going to be at about 55, 50, 56, 58, 100 meters above sea level. That'll be your altitude. So the bottom line here, as pressure decreases, altitude increases. As altitude decreases, pressure increases. So the closer you are to the Earth's surface, the higher the pressure. The higher you go above the Earth's surface, the lower the pressure. You got to, later on, this becomes important, why my rocket failed. So this is very important. So I use this to test the rocket. So I basically built my own little vacuum chamber. I went to the dollar store and I got a sealed, airtight Tupperware container, and I just drilled a hole and I put a plastic tube and I sealed it with hot glue. And I've got this big giant syringe here, and I've got some wires for like power and stuff like that. Again, hot glue. It's sealed. So the lid goes on top of this, seals this airtight, and as I pull this plunger back, the air pressure in here decreases, so it simulates it going up in the atmosphere. So that's how I was able to test it. So here's a video showing me testing. This is an actual board that I got from JLC PCB. So as I pull the plunger back, the rocket is going up, and you'll see the container lid going down. And as I push the plunger back in, it's as if the rocket's coming back to Earth. The pressure's increasing. And you can hear it beeping out. My altimeter's beeping out. So this video is showing the downlink, showing what the other ESP32 will be showing as I do that plunger test. Let me just skip ahead here. So right here, it's trying to get a connection to the module. It's timing out. It's just working so there it's finally got a connection. It says it's armed and it's connected. ESP's connected. And so I'm pulling the plunger out now. So as I pull the plunger out, it says it's launched. It detects a launch event. And then I'm pushing the plunger back in now. So it's determined apogee and it's fired the deploy charge. So this is an E-match. So this is what we use to fire an explosive charge. So we've got like 1 or 2 grams of powder, and we got that in a little seal container. I used a straw. I put the powder in the straw, and I taped the ends. I put the match in there. So this is just a video showing what happens when that match lights and when it gets to that deploy event. So that's how see it fires. It's an actual match. That's why it's called an E-match. So, and here's a test I'm going to be showing with an actual E-match. So this, let me pause this video. How do I pause this? Hello. Oh God, my mouse just went dead. Hang on a sec, guys. Sorry, guys, my mouse just went dead. I got to put a battery in it. Okay, there we go. That's what happened. My mouse went dead. Sorry about that. So let me go back to full screen. So this, I'm going to be doing an actual test here with an E-match. So that's a commercial unit I've got in the my vacuum chamber. Here's my home built, and this is another commercial unit. So I always test everything just to make sure it's working. So this here is showing a test of the unit. There's the E-match. So there, I've got the plunger, and you're going to see me connecting the power. There's the E-match right there. You can hear it beeping. Those fast beeps means it's seeing a charge. It's good to go. And you're going to see me there. I'm simulating it going up. I'm pulling the plunger back. Okay, it's launched. And then I start pushing it back down. And so once it reached that dual deploy, it fires the E-match. So that's working good. So I also did that static testing. So I also that's a prototype. I loaded it up on my drone, and that's in my backyard. And I go to my downlink here, and I'm enabling it. I'm getting everything ready. I'm setting up debugging so I could see what's going on. And then I go over. Here's the drone controller. And so I punch the drone, and I let the drone go up into the air, and I simulate a launch, and I check to test it to make sure it's good. Key thing there, that's low G. That's going up very slowly. So here's the actual altimeter bay that's going into the rocket. Here's my homemade electronics. It's got 2 bolts here that the charge is connected to at the other side of the bulkhead here. And here's the underside. It's showing the commercial unit, because I always put 2 for redundancy. I've got this as primary, that's as backup. Here's the battery. You can see the Wi-Fi antenna taped down. Everything looks good. So launch day. So here's the rocket, that blue flame rocket here. It's on launch day. You could see a pole here. See that little stick? That's what my downlink, the GPS and the little 3D printed case. It's on there, and it's taped to this post. There's a little USB cable. That USB cable gets connected to this USB cable and plugged into the laptop. So here's different views of me prepping the rocket. That's the actual size of the motor that's going into the rocket. That's the I-280 motor there. It's pretty big. So here's the rocket at the launch pad. That's a ways away. Here's a close-up of the rocket on the launch pad. You could see the igniter cables. They have launch cables, igniter leads that goes and fires igniter, which launches the electronic. That's my selfie, the rocket there in the background. So this is on the pad at the rocket launch that was a couple of weeks ago. So here's the actual launch here.
I'm not going to look at your last name, Dave, from Paris, Ontario. Flying Blue Flame and homemade on A3. That one, I-280 hard. On just the side of the
And right at that point,
I'm not going to look at your last name.
did you hear someone go, "Oh"? You could hear someone going, "Ow!" The rocket just kind of spun out of control and just split apart. So the rocket failed. So here's the other rocket. I flew this rocket. Tyler and I made this about 3 days before the rocket launch. We just kind of quickly threw this rocket together, built it, took it down. There it is on the pad. I'm going to fly it in an F50 motor, which is a model. That's classified as a model rocket motor. And so here's the launch here.
Pronounce your last name, Butchman. Flying Tyler's Legacy, homemade on an F50 in 5, 4, 3, 2, 1.
So this rocket flew great. So this did an apogee deploy.
All right.
So it went up and
C6 and C6.
there's it coming down there. There's the
5,
chute.
4, 3, 2, 1. Oh, that did not work right.
So that's the rocket coming down. So here's a still of showing my blue flame going up. And you can see it's a Sparky, what's called a Sparky motor. So it's just a whole bunch of, it's got all these aluminum specks in the motor and it creates sparks coming out. And it's a really nice effect coming out because you get all these sparks on the ground. You don't want to be launching this in dry grass, stuff like that, because you'll start a fire. But it's a great motor. It's a black smoke and you got the sparks coming out. And here's Tyler's rocket coming off of the pad. There's nothing, just a little bit of smoke coming out. Can't even see a flame coming out. So what happened to my rocket, to my blue flame rocket? So here's the actual payload bay. So after the rocket's on the ground, I recovered it. This is the carnage. So here's the payload bay. You can see the two charges. Two straws. Remember, I said I used straws. So those are the straws there. Both charges went off. You can see that's all black from the charge. That's a little piece of the motor there, but nothing revealing there. That's what it's supposed to do. So the first bit of damage, this is the parachute. So now a parachute has a canopy and then it has shroud lines. The parachute got ripped completely from the shroud lines because it deployed right as it was going up and it just ripped the parachute apart. And also too, this is one of the tubes. Here's the shock cord that goes inside and it keeps the sections together so they don't blow apart. Well, this shock cord ripped through the airframe tube and we call that a zipper. It just ripped right through. Now, this tube is very, very, very strong. And for it to do that, it takes a lot of force to zipper that, to make that force. So here in context, here's the Tyler's rocket. That's the size of the motor compared to the size of the rocket. This is just one part of the rocket. That's the part that got damaged. That's the size of the motor that actually flew in it. And there's the shroud for the parachute cord. So what happened? So remember I said I got all these files. I got log files and I got data and all this stuff. So what caused my blue rocket to fail? So here's my log, the logging file. So if we go through the log, we see it starts up okay. It's got a GPS log. It spits out some calibration data. It spits out the time of the launch. It's got 6 satellites, blah, blah, blah. So it's got the launch detected here. It says launch detected. at 1005. That's pressure altitude. That's above sea level. So above ground, AGL, above ground, was 46 feet above ground. It detected launch, and it was about 10 Gs. It experienced about 10 Gs. Now, keep in mind, I think pilots fly like, what is it, 6 or 8? And I think, around that kind of thing, you black out because the blood, there's so many Gs, the blood drains from your head and you black out. High Gs can do a lot to affect things. So that rocket was seeing 10 Gs. So then I've got this tick counter, and it counts number of milliseconds. So it's saying it reached apogee 176 milliseconds later. So just, couple hundred milliseconds later, it says it's at apogee. And the altitude above ground is 16 feet. Hang on. So it launched at 46 feet, but it opened at 16 feet. The altitude is decreasing. That's kind of weird. So then it says it deployed. So here's what happened. It deployed the charge to open the rocket 267 milliseconds into the flight. And it said it was at 30 feet. Hang on, 46 feet, 16 feet, 30 feet. What the heck is going on here? This altitude is not right. So something's going on with the altitude. So now we go to my bin file that's got all the data from all the sensors. And there's a command where you could take that, you could dump it to a CSV file. And that CSV file, you could print it out in Excel. And so this is what you get. It's got the states. AL means armed and launched. ALA means armed, launch, apogee. So the green means it detected apogee. And the blue here, it's saying armed, launch, apogee, and shoot. So it deployed to shoot. So sure enough, about 300 milliseconds into the flight, it deployed to shoot. Now here's the pressure altitude. This is in sea level. This is not AGL. This is above sea level. So this is basically at ground level here. So if you look at the altitude, it's decreasing. So which means the pressure is increasing. Because remember, as altitude decreases, pressure is increasing. So the pressure, it's recording a higher pressure as it's flying. So that's kind of really, really weird. So, and keep in mind, it's seeing a ton of Gs here. Like it's seeing almost 14 Gs at when it detected apogee and it deployed to shoot. It was undergoing like 14 Gs. So theories. So what happened? This is what I think happened. This is one theory, theory number one. So now if you've got a payload bay, okay, it's got a vent hole and it's stagnant air in there, right? If you take this and you accelerate this to high G, it's like taking someone, a pilot, and accelerating him to high G, the blood drains out of his head. Well, the air is going to get pushed to the bottom because all of a sudden you're accelerating this rapidly. So all the air gets pushed to the bottom and you get a higher pressure at the bottom. So the altimeter sees a higher pressure. So that's theory number one. Theory number two is that here's the payload bay, here's the vent hole. I took this picture, this is the only picture I have that shows the vent hole, and I was painting it. So I took this picture as I was painting the payload bay. So you can see it's got a single vent hole here. Now, on the day that we launched it, we had winds upwards of 27 kilometers an hour. And we had gusts going up to 37 kilometers an hour. It was a very, very windy day. They canceled a lot of high power launches. My launch, they wouldn't launch it. I had to wait almost 40 minutes to get a window to launch my rocket because it was so windy. So if you got the single vent hole, you got all this gusty wind. Well, the wind might blow air into this hole and may increase the pressure inside this payload bay. Now, a lot of my rockets have 3 vent holes, so they've got, at 120 degrees. And the reason you do that, in case there's air pressure coming in, any wind or pressure for sideways motion of the rocket, it equalizes inside. So inside doesn't undergo high pressure. And that's why airplanes will have 2 static ports on either side of the airplane, right? To avoid this kind of thing. So this rocket happened to have 1 vent hole, and I've flown it before and it worked fine. So maybe I got bitten by having 1 vent hole. So that's basically it. That's everything I wanted to say. Whoops, how do I stop sharing this? There we go.
Yeah, I'll go first. What's the price tag on some of these rockets? Or sorry, the motors.
Okay, that F motor I think was about $30 or $40. The motor I bought, the big I motor, I think it was about like $100 or something like that. Certainly not cheap. The big K motor, you're probably spending $150, $200 for that motor.
Holy cow! Who was next? Was Peter?
Yeah, Dave, very interesting and good. I think you probably. I'm thinking your first theory is probably the one. That's the one that came to mind for me, anyway. But that's really cool. I'm curious though that you were saying earlier on about the ministry approvals. Do they give you a blanket approval, or do you have to call for every launch?
You have to call NAV Canada. Transport Canada gives you approval that says you can launch, but then every time you launch, you have to get approval from NAV Canada. Just like flying you go to take off an airplane, okay, and you're flying into control airspace, you have to get permission from NAV Canada, not from Transport Canada. Transport Canada takes care of licensing, airports. They take about just the whole everything else, and they've delegated airspace and control of airspace to NAV Canada.
What was it? My next question. Oh, when the chute prematurely deployed, did the rocket start to go sideways? In other words, did people start to duck and run, or what was its flight path like?
You're far away from the flight line. Those pictures, I was zoomed in,
yeah.
But you're a good 200 feet from the flight line. You're a ways away from, because that's the high power rockets. They make sure it's away, and then they even have a pad that's like 500-600 feet away. And it's way far away, and that's the stuff they're going to launch the big M motors and N motors, and the big motors. They're really far away.
So what kind of a flight profile did this one take? Did it go sideways, or?
What's that? Sorry?
What kind of a profile was its flight? What was the flight profile? Did it kind of go up, the chute got deployed, and then it kind of went sideways, or what happened?
The rocket goes, when a rocket becomes unstable, it just spins. It just flies crazy. There's no path. You can't predict it. It just spins and flies crazy.
Okay, thanks, Dave.
Michael?
So, Dave, the Saturn V, the guy launched, was it a multi-stage thing?
No, it was apogee deploy. So in that rocket, he used car airbags. He got airbags from cars. Instead of using an ejection charge, he used an airbag. I think he had 2 or 3 airbags, and he fired those to open the rocket up.
I guess that's a one-time opening, right? You can't use it after. You can't rebuild it. It's gone.
Well, you put it back together, and you got to use airbags again. You got to use fresh airbags.
Okay. Oh, wow.
But that's Google it. It's really, if you Google it and you look at the YouTube video of that launch, it is pretty impressive. You'll see the crane. he had to bring a crane to the field to lift the rocket up and put it onto the pad.
Pete?
Yeah, Dave, I wonder how much it would have cost for that motor on that Saturn V?
He said it was about $10,000.
Holy.
Yeah, he paid about. Now he didn't pay that out of his pocket. He got sponsorship. The guy like Napas flying that end motor. That end motor was probably, I don't know, $5,000, $4,000 for that end motor. You know, they didn't pay for it. They got that free. They would go to most of these guys that fly those big motors. They go to the manufacturer and they say, "Hey, I'd like to get a motor and blah blah blah," and you know, and all of a sudden the manufacturer gives them a deal. Like Cesaroni is a huge manufacturer of rocket motors. He started the Napas Club. So he makes rocket motors and he makes commercial rocket motors for like, missiles, and he makes for boosters and for Wallops Air Force Base. He makes commercial rocket motors. So whenever we were flying those big motors, he just give us motors, you know?
And I think Eric.
Yeah, so last time I was at LDRS, interesting things were launched. You mentioned the grandfather clock, I think, but there was a snowmobile, if I'm not mistaken. Was there anything of the sort this time?
It was a terrible weekend. It rained Thursday. It rained Friday. Saturday was the only clear day, but it was windy as shit. And Sunday it rained. So Saturday was the only flying day, and they had a full-scale Patriot missile, a full 100% scale Patriot missile, 600 pounds. They were going to launch. That was going to go up, I think, to 10,000 feet. They were going to launch that, and that got scrubbed because it was just too windy and there were too many clouds. They couldn't launch it. Like even to launch my motor, my rocket, it was supposed to go up to 4,000 feet. They couldn't launch it. They had to wait until the skies opened up, right? Well, my rocket only went up 50 feet, so it didn't matter.
Right. Yeah, you probably could have thrown it up higher with.
Yeah, that's right. They could have.
So what was the biggest motor used that weekend with those 4Ks? Was it? I think.
No. That's the that was a launch, and as I said, most of the videos I showed was from a launch in 2015.
15. Okay. All right.
That was
So
what
was the biggest motor used a couple of weeks ago? Do you know off the top?
I think they flew an M. I'm pretty sure I'd heard them flying an M motor because earlier on in the morning, the sky was clear, and so a couple people did their L3 level 3 certification flights, and you got to fly an M motor, and they just ripped the sky apart. A few of them just came up and just exploded, and just shrapnel everywhere. So, but that's common. You know, seeing rockets blow up at LDRS launch, that's a common thing. That's nothing everyone's going to go, ooh, you know, it just, you know, everyone holds up cards, 3, 5, 10, you know.
Okay, so no snowmobiles, no guys in jetpacks flying over the crowd, none of that.
No, it was too risky of a day. They flew the interesting thing though, they had a barrel full of rocket motors, just model rocket motors, and they had a whole bunch of free rockets. So kids could come up, all these rockets were built. Kids could come up, grab a rocket, go in the barrel, grab a motor, stick it in, take it to the launch and launch it. Oh, nice. So they were really trying to encourage kids to go and launch rockets. They launched a lot of model rocket motors, a ton of rocket model rockets, model
That's
rockets.
Good. Okay, I'm full of questions. Two more questions. Two more questions. One semi-serious and one an Eric question. The serious question is a lot of your electronics tends to be pretty sophisticated, I would say, relatively speaking.
Overcomplicated?
The first thing,
Overcomplicated?
yeah, excuse me, my brain is full. Can I be excused? But like you can go very simple. Like the first thing that you would have put in one of your early rockets would have been just a simple altimeter, perhaps, or
Yeah, and the code would be this big.
Right,
But
right.
I had to put a downlink and Wi-Fi, and I had to put all this stuff in a CLI, and I take this and I make it like this.
Right.
That's my style, right?
Did you have like mission control set up, like multiple panels, and
And here's the thing: at these launches, you don't have time. So I had all this telemetry data coming back in real time. You're watching the rocket. You're not watching a screen.
But you had a team with you, right? A whole bunch of guys with white shirts, black ties, and brush cuts or whatever, and headsets. No,
I should have. That's what basically you need.
Yeah. Okay, last question. Silly question. Has any amateur rocketry ever been able to launch anything high enough to get into orbit? Is that actually possible?
There has been guys who launch. You need special approval to go and do that. But there are some guys who has launched, not in orbit, but to get up, where you could see the curvature of the Earth.
Right.
There are some guys who've done it, but they're going to be doing that down in the desert in New Mexico or like Arizona, because that you got to get special permission, and all of a sudden it's like red tape. Because
isn't it better to ask for forgiveness for that kind of stuff? No.
You go, you fly that. You're gonna have a couple of what's the new fighter jets the US have? You have a few of those coming around you.
You might have Agent Smith come and visit you. Okay. So is it actually, do you think that's possible though for amateur rocketry to get into orbit?
There's a guy in St. Catharines back in the mid 2010s, 2012, 2014 kind of ish. There's a guy in St. Catharines called Richard Naka, and he had this thing, Sugar into Space. So I don't know if you guys know about sugar motors. People make their own rocket motors out of sugar. Eric, remember at one point I was going to make rocket motors out of sugar? I still have all the chemicals. Yeah, and so so he was sponsoring this thing where he wanted to fly sugar motors and fly his rocket into space. I don't know whatever happened to that. I never followed him. But it was a guy, a big guy, Richard. I want to say big guy, a big name. If you Google Richard Naka, Naka, you'll see a whole bunch of stuff come up about him. The guy's really active.
Maybe he got visited by Agent Smith. So
maybe. Yeah. But here's the catch: you can't make sugar motors in Canada. It's illegal. You can't make them. You can't operate them. You can't test them. It's illegal.
You're also not supposed to jaywalk.
Yeah. Well, yeah, and then you're not supposed to go on the air and carp and go, but you still get people doing it. Right?
All right. Okay, enough silliness. Thank you. On to Cherry. Sorry.
Yeah, where is this events happening actually? This you're doing
there's rocket launches all over. There's a club in Ottawa. They launch rockets. There's a club in Quebec. They launch high power rockets in Quebec. There's 2 or 3 clubs upstate New York. This rocket launch was in upstate New York. It's called LDRS, Large Dangerous Rocket Ships, and it flies all over the U.S. So next year it might be in Montana.
So you went to LDRS?
Sorry?
You went recently to LDRS?
No, yeah, that's the launch. I was at that. It was in upstate New York. That's the first time since about 2015, 2014-ish. It's been in upstate New York, because upstate New York for me it's close. Like it's only 2 hours from Buffalo, hour and a half from Buffalo. So it's literally about 3 hours drive for me doorstep to doorstep.
And it's also held in conjunction with LDHF, right? Large Dangerous Ham Fest. Yeah.
No, large dangerous ham. Not well. And one of the things I used to do is the big thing I had was to put amateur radio transmitters in these rockets and launch them. But anyway, enough. Ken, I think you need some time to talk, right? So I'll shut up.
Not very long. It's going to be quick. Okay. So I'm going to share. Where's share here? Share. Start sharing screen. Entire screen. Share. See my screen, guys?
Yep, looks good.
Okay, so just a like a 5-minute, 10-minute blurb on the DCR. We're at the point now to start kitting these things. In the picture, that board is the last version. We've got a slightly updated version. So, input via full power, audio out, volume control, bandpass filter, SA612, LM386 audio, power supply. Two bandpass filters are built, one for 40, one for 20. All these bandpass filters were based on information I found in I think it was a chat or a blog, but it doesn't matter. Very simple, 2 caps and an inductor. Very simple. And just to put it on a bigger piece of paper. So 40, 20, and 10. There's the cap values, C2 values, and L1 values, and it has all the toroid sizes, and number of turns, and expected inductance. What else was there? Schematic. Okay, this is an old schematic. I just realized it. It's been updated slightly. So we've got the power supply right here. So we got our 12 volts coming in with a power light, LED power light. 12 volt is feeding everything but the SA612, and that's where this voltage is coming from. We've got our RF jack input, bandpass filter, test point, SA612 with the test point. We got several test points throughout the circuit. Volume control, another test point into the LM386, another test point to audio jack. This is the VFO input. This attenuator setup in regards to using the Park SIGGEN because of the output level. I think I got it set at 13 dB attenuation. If you want to use something else, you may have to either change this, or if you're using, say, like an RF generator, then what you want to do is leave these 2 resistors out, short this across, and you can adjust your peak-to-peak voltage on your RF generator. What else was there? Now, pricing-wise, I had a call with Peter, was about 3 weeks ago, I think. Now, looking at parts, all the stuff above this line is parts from DigiKey. It comes on at $22 without tax, without shipping. So that would be the price for one kit. And of course, the more kits we order, the cheaper each kit price will be. this here is the price for parts that Frank had purchased quite a while ago, and those parts, the cost of those parts will be going back to Frank, except for this one, the RF BNC connector for the board. Uh, DigiKey wanted almost $7 without tax. I found them on AliExpress for I think I've got it right here, $1.20. That's including tax and delivery. So we saved a little over $5 for those connectors, and they work just as good as the ones that come from DigiKey. There is some free stuff here, and these are things like male headers, female headers. I have a pile of PC board edge female SMAs, and we got a ton of power jacks. So this stuff is free, and I've got it all sitting in a bin at home here. And then this stuff is the cost of each bandpass filter. What I'm going to do is you're going to have a choice. What I'm including is 2 Vera boards, the size of that would fit the headers, and it will include the caps, toroids, and wire to make one for 40 and one for 20. And then there'll be 2 spare ones that you can experiment with. Or if you'd like down the road, you can buy a QRP Labs kit and a filter kit and put it in yourself. Also including the wire as well. So in meeting with Peter, we looked at a price coming in at about $40.
Hey, Ken,
Yeah,
that DigiKey price, what's the most expensive part on that list?
it is. Oh, I don't have it on this sheet. The audio jack. Actually, there's an audio plug and a jack, and they're both the same price. It's like $2 and some cents. The RF connector was the most expensive one at $650 plus, and I got those from AliExpress. The PC board was $1.60. We figured out that's taxes in. So overall price is about $40. Now, in meeting with Peter, we came up with another idea was to the kit will not include all the parts, and the reason that Peter came up was he says he's got a lot of this stuff here in his junk box. So why spend $23 if you've got it? So what the kit would include is the board. It will include this stuff here and this stuff here. So we're looking at 9, 11, say $12, $13. And all this other stuff here, you would either have it in your junk box, or if you want to source it somewhere else, that's fine. Or what I'll do is in the manual, I include a list of all the DigiKey parts. And if you want to order them from DigiKey, you can do that too. Be a lot.
And I would suggest that you include the audio jack.
It is included.
No, you said that everything from
I see.
DigiKey is excluded. So include because if it's $2, right? Include, because for us to go, because that's a component that you're going to have to solder to the board. It's a specific.
Oh yeah, okay.
That, or maybe now, do you got the BNC connector? That's included in the $8, right?
Yeah, right here.
Yeah, because to me, the BNC connector and the audio jack is probably the two most critical things that you're going to need. Everything else, yeah, you could get potentially from your junk box.
Well, the power jack you can't get from your junk box, but we got a pile of them in our bins here that we got free years ago. So that's included.
Yeah, I got a ton of them. You could get them from AliExpress for like nothing.
Yeah, I know. And I've got them all for nothing. So that power jack's being included too. The only thing with the audio jack, I've got to order them then because I don't have any. What did they say? Well, oh, I didn't have a price. I think the audio jack was about two and change, something like that. But yeah. Anyways, um, so you want to add something, Peter?
No, I was just going to say, I mean, the whole premise was came out there when we were discussing it was that, I mean, all of us have been here, have been home brewing for quite some time, a number of years, and I'm sure a lot of those parts are in our junk bins.
Yeah.
I mean, maybe I'm wrong, but I think pretty much we all have junk bins that would support this particular project for the most part. So that's why we kind of came up with that idea.
Yeah. When we were with Park, the homebrew group was a side group of the Park group, and anytime they ran into high price projects like the SMA, uh, the main club would front the money, and then at the buildathon, the money was collected and returned back to the club. We don't have that right now. Um, I'm like even the price of all this stuff together. I'm willing to front it up, front it in the beginning because it's not that expensive, and just recoup on kits. But I guess Peter, I don't know how we want to handle this. Do we want maybe post something and find out who's interested in?
Well, I think the next step is. I mean, does anybody have any opinion on like the partial kit thing? And does everybody here have a decent junk box who's interested in building this project?
Well,
Peter, why don't you just go around the group? Just go around, poll everybody. Just quickly go around and just poll everybody and get their interest.
Okay. Well, Ken, you're in charge, so you go ahead. You see the screen, go around.
Let me see. Well, me, I don't care. I've got like 2 or 3 versions of it, so it doesn't matter. Oh, I gotta stop sharing here. I am okay. Bob. Oh, Bob. Well, I don't know if Bob's interested or not. Charlie, would you be interested in it?
Yeah, I'd certainly be interested in playing with it. My junk box is pretty pretty well packed. I think I would have most of those components and probably even the audio connectors I would like to have in my box as well.
Okay. Well, as far as the audio jack goes, we could not include it in a partial kit, and if they want it, you can order it, or you can find an AliExpress equivalent for it. Dave?
Yeah, for me, I just got the board. I would get most things. The only thing I would want is the BNC connector and the audio jack. Everything else I got.
Yeah. Okay. Drew?
Well, I'd have to look at the parts list. I think I saw some SMDs in there, and I certainly wouldn't have those. So,
Yeah.
I don't have anywhere near the kind of parts bins that you guys have.
Yeah. Yeah. Well, you know what? We can make a formal posting on the groups there and explain everything.
I think that's best. I mean, it's a great idea, and I would be really interested in building it, but I would be hard pressed to come up, I think, with most of the parts.
Yeah. Okay.
Anyways, it's a really great project. I like it.
Just interrupt for a second here. Ken, was it SMD caps and resistors, or were they through hole? I can't remember now.
All SMD. Only the attenuator resistors were through hole.
Oh,
to
okay.
make it easier to change them if you had to.
Okay.
Eric, of course, yes. I'm going to say yes for Eric. He has no choice.
Yeah. I second the suggestion of making a list. DigiKey, I think, has this list you can share with collaborators and all that, like the my lists or whatever. So just make a preset list, and then if possible, with populated with all the parts, and then people can delete things they don't need if they already have it in their bin, and go for it. So I'm kind of similar to Drew there. Like I probably don't have a whole big backlog SMD components. So anyway, yeah, DigiKey my list. Make it once, then everybody can benefit that wants
Yeah.
the parts.
Yeah, I can make a secondary shopping cart with only the necessary parts with DigiKey, and then I could share it with everybody. I could share it on the groups.
Yeah.
Yeah.
Okay. Well, just so you know, you might want to check into, if you have an account with DigiKey, this my list thing, and then you could just, I think, share a link, and then everybody gets it. I've seen that before with other projects where you just punch in a URL and it populates a shopping cart with everything. So
Yeah.
it's called my lists. So
Yeah.
anyway,
Okay.
Thanks.
Frank? I know Frank's going to say yes.
There we go. I've pretty well got everything over the years I've collected, but I would not have the proprietary stuff like the circuit boards themselves and anything special that I couldn't get off the shelf. So I'm in anyway. Looking forward to it.
Okay, excellent. Well, you've built like 3 versions of it as well.
Yeah.
Mr. Hassan. Mr. Hassan. Oh, he's not around. Michael, you had your hand up first of all.
No, I was just going to say that I forgot what my hand was up for, but basically, I and Daniel of E3 and I would like to build these.
Okay.
We have very limited supply of parts. I doubt whether I would have any at all because I just haven't been collecting this stuff. So I have virtually nothing. So I'd like to get the complete kit one way or another. The list sounds good. I mean, you could order it that way. That'd be fine too.
Yeah. Okay.
But I'm in for 2 anyway.
Okay. Peter, yes. Jerry, I'm assuming yes.
Yes, double S.
Yeah. Okay. Wayne.
So I could probably find all the parts in my toolbox. Before this discussion started, I was thinking about buying a full kit, and then maybe begging for an extra board so that I could try it on my own and maybe modify stuff. So it works either way. If you end up kitting up anything with all the parts for somebody, then I would probably order that.
Yeah. Okay. And then there's people not in the meeting, like Kevin. He'll take one. Actually, Kevin was still willing to write the manual for it, which is going to be it's going to be a soft copy, not a hard copy, and that way we could distribute it easier. But maybe Peter, maybe we can get together on the weekend or sometime, maybe Sunday, and come up with a posting, maybe that we could put up with all the details of doing a full kit or a partial kit. And probably Sunday would be the best for me. Saturday's already booked up.
Okay.
So we're looking at 1, 2,
10, 11.
10, 11. I don't know. Maybe we can send something to Bob. Bob, would you be interested? No, he's gone.
You scared him off.
Yeah, that's okay. I think there was 12
Bob is back.
Oh, he's back. Probably lost audio.
Connected. Yes, I would be interested, at least in the car. I probably got all the spare parts in my junk box, but I would be interested.
Yeah, and besides, DigiKey is half the price in the States as it is in Canada.
Okay.
Okay.
I should buy it for all you guys and then send just one package up there.
There you go.
You can't. It's illegal.
I'll meet you up in Hamcation. How's that?
Yeah, they can do that too. No, actually, if you actually place an order on DigiKey at the checkout, it asks you if you're selling this back out, and you wouldn't be able to do that, Bob.
All right.
Well, you could probably do it, but you can get away with it. But who's going to check on you anyways? But here, DigiKey, the DigiKeys in Minnesota. They back, I don't know, probably 8 years ago, they actually opened up a warehouse in Winnipeg, Manitoba, at the airport. That's how quickly they are be able to dispatch all orders. Um, I know all my orders come in one day from Winnipeg.
Are the prices actually with exchange that much cheaper in the States?
Probably about 35%.
Huh. Interesting. Okay.
Hey, Ken, another option you've got is that what we could do on those connectors, the power, the audio jack, the BNC connector, we could just put in footprints. We could just put in a header pad, like a pad for a header that you could solder your own wires to, or you could put wires and put any connector you want coming in, as opposed to having a specific port where it's just open. You could do anything you want. So we could kind of do that as well too, because like for me to go change that, it's nothing on the board. Or if we want to order some boards the way it is, order maybe 5 or 6 that way, maybe order 5 or 10 the other way, it's going to work out the same cost, right? We just need to know which board people are going to want.
Or just duplicate the pin header. Just put a spot in there for the pin headers and keep the existing footprints for the jacks as they are, and then just add. I think that's Dave.
That's a good idea. You could also keep in mind in the footprint itself, you could just solder wires to the footprint, because the footprint is through hole, right?
Yeah, we could do
so
that.
In the manual, you could just have how to put your own wires on there, as opposed to getting jacks and stuff, right? So we don't have to do a thing.
Yeah, the other question is do we want to do this as a build-a-thon?
I don't know. It's we got people in Kingston, people here. Dave's out in Paris. Frank's out in Amherstburg. It might be difficult.
Well, anything we do is going to be difficult to get together if you look at it that way. But I know we're running out of time, but it may be food for thought. Everybody think about as a build-a-thon. It looks like we do have a location. Thank you, Michael, for something. So,
yeah, I was just gonna say we do have at the club station, which is on Anson Drive, just north of the airport in Toronto. We do have a space we probably put 6 or 7 people. Any more than that would be really tight. But with that space is available, I guess, if we needed to do it. So it's a possibility anyway.
Okay.
All right. 5.
Maybe it can be an online build-a-thon.
Yeah, it could possibly. We'll have to see, get people's opinions. That would probably be the best and easiest way to do it. And then there's some people who have been out of contact because of COVID, and want to get together to socialize too, like we did in the old days. But like again, you got people in
It
Kingston.
might be both. You might have some people that can, maybe the guys from Kingston and Pembroke and all that kind of stuff, and Atlanta are not going to make the trip to Mississauga. But maybe there's going to be 5 or 6 guys in the GTA area that will get together.
Yeah, like Mississauga is not far from me, right? So make it a hybrid, right? Those that want to go down to Michael's offered venue, then fine, and then we'll just have a whatever, a monitor and a camera, and those
Yeah,
that
I'd
want
be
to
okay with that.
zoom in or jitsi in.
Yeah.
Right?
I say we go to Bob's.
We'll make it a 6.
Yeah, but in the cold weather.
Yeah, Georgia's nice this time of year.
Yeah.
Even it doesn't. What's the guy's name? The guy who's a big pilot. What's the guy? He's got this Tyler Perry. Doesn't he have the big studio? Isn't he from Georgia?
Yeah, his studio is down here. But you guys can
No,
come
but
down and
his house. Have you ever seen his house? He's got a airport at his house.
Okay, it's a 17-hour drive to Atlanta from here.
He doesn't have a private airport. He uses one of the county airports. And if you guys have got a plane, there's a county airport that's just a mile and a half away from me. If you're gonna fly.
You're 17 hours, Bob. You're safe.
I say what we do is we get together and we go down to Bob's for a 6-month-long build-a-thon.
There you go. Like, I mean, it's 95 Fahrenheit where I am today. What is it? 195 in Georgia today?
No, today was cold. It was like 86.
Oh my God.
Yeah, and I even went to the beach. I couldn't ski, but the beach was still good.
Good night, Wayne.
All right, guys, let's wrap this up. Maybe Peter and Dave, we could get together on the weekend. Saturday's a total write-off for me. I won't be around at all, and we could do something on Sunday if you're available.
Sure.
Okay.
What's your schedule like, Dave?
Yeah, weekends typically. This weekend I was free because I was planning to come out to Eric's for a field day on Saturday because the wife is out Friday night. She's visiting some friends. That's okay. I'm gonna go hang out with Kevin. There's a food truck festival in Stratford. We're gonna go, but he had one condition: no radio. He said, "Come on out, no radio."
I wouldn't know. How can you not talk about electrons at some point?
Yeah. Okay, guys, let's wrap this up.
All right.
All right, guys. So it was a good evening today.
Yep.
A lot got accomplished and some good presentations. All right, everybody, have a good night and have a good rest of the week. And Dave and Peter, I'll contact you later.
Okay.
Thanks, Ken. Thanks.
Okay.
Thank you.
Good night, everybody.
Good night.
Good night to all.
Night.